All right, 3.4, properties of logarithmic functions.
Oh, I see. I remember kind of a little bit.
I still have a stupid calculator.
Oh, I'm sorry that your calculator's stupid. I'm ready for your calculator.
Just deleted the part.
So we have a product rule that says that the log of a product is equal to the sum of the logs. So the log base b of m times n is equal to log base b of m plus log base b of n. And that works in the reverse direction as well. The quotient rule. The log of a quotient is equal to the difference of logs so if you had log base b of m divided by n, that would be equal to log base b of m minus log base b of n. And then the last one is the power rule. And we just say throw it out front. So log base b of m raised to the c is equal to c log base b of m. And sometimes, like, all of these rules will end up combined in one, so you just have to go through and, yeah, anyways. Just use them all together. Okay, so examples. All right, assuming x and y are positive, use property of logarithms to write the expression as a sum or difference of logarithms or multiples of logarithms. So if they have multiple things involved. So let's start with number 2, ln of 9y. So we're trying to go from it being compressed to being expanded, basically. So we're trying to write it as, well, it's being multiplied to the sum of logs. So it'll be ln of 9 plus the ln of y. Now, I would leave it that way, but just so if you're going through and checking problems, if you see something like this come up, this is what they're doing. They would say that ln of 9 is the ln of 3 squared. So then it would be 2 ln of 3 plus the ln of y. I don't personally see a need to rewrite it. This is how I would do it, but this is how your book will do it. So if you're checking your answer and yours doesn't match, look and see if that's what they did, basically. I will take either one, though, so if you're like, well, I want to make it look all simplified, that's fine, but I would have just left it as the first one. So. Let's see, 4, we have the log of 2 over y. So this is a quotient, meaning that I'm using the difference. It's always the top minus the bottom. So remember, if there's not a base written, it's log base 10, it's common log. So this would just be log of 2 minus the log of y. Six, log base 2 of x to the negative 2. So based on my properties, what would I do with this one?
Throw the power out in
So -2 log base 2 of x. Number 8, log of x y cubed. So I'll tell you with one like this, okay, because there's two things that ultimately have to be done, because we have something that's being multiplied, which is going to give us a sum, and then we also have something being raised to a power, meaning it has to go out front. I am okay if you do it all in one step. Okay, but I'm gonna write both steps just so that we see it while we're getting used to them and stuff. But if you wanted to just jump to the final step, that's completely fine. That's honestly probably what I would do in general. So we would have log of x plus log of y cubed. That cubed is going out front, so this would be log of x plus 3 log of y. So I'm okay with you going straight to here, but it does have to be simplified all the way. Okay, so there should never be a power left inside the log. All right, so the next one, number 10, log of 1,000 x to the 4th. So how would I write this one?
Log 1,000 plus log of x to the 4th. You have to put 4 in front.
Yeah. Now, again, if you were to leave it there, I'm okay with that. However, the log of 1,000 is actually a number, so the book will rewrite it. So think about this as log base 10 of 10 to the 4th power plus 4 log of x. So remember, the 10, with that, they cancel, and it gives you 4 plus 4 log of x. So this is how your book will write it. I'm okay with you stopping here, though. Or wait, this is wrong. This is a 3, not a 4. So nobody wanted to catch me on that.
I thought about it and I was like,
I could have had a 6 cookie
I'm trying
point.
not to fall asleep over here. I'm just so tired. Well, I wasn't tired in first period, but now I'm just like drowsy.
All right, 12, ln of the cube root of x over the cube root of y.
Interesting.
So what initially do I need to do?
Do the subtraction.
Like, yeah.
Subtraction first. So the ln of the cube root of x minus the ln of the cube root of y. Do you think I'm done?
No.
No.
Can you square both of them? Or no?
Can you,
I mean,
like,
not square.
take
I meant
the-
cube.
Yes.
So what's another way to write a cube root?
Good question.
Is it like x over something? I don't know.
Got me.
Some type of exponent.
A 1/3.
Okay, so I would rewrite this as ln of x to the 1/3, and you could have rewritten them over
Smart
here.
Josh.
Minus ln of y to the 1/3. Now what?
Oh, you
Move
have
the
to
power out.
put it up front.
Yeah.
So 1/3 ln of x minus 1/3 ln of y. And do you see anything else that we can do?
Can you cancel out the 1/3?
I can't cancel them.
You can subtract them.
Hmm?
It's already
Maybe do
subtracted.
ln x
Like all
minus
the way.
ln y over 3? Wait.
Okay, technically that is what I'm, yes, basically. We're taking the 1/3 out front, but that is basically what it ends up being. So 1/3 times the ln of x minus the ln of y, or what you said would also technically be fine.
It's like undistribute.
Yeah. Factor out the greatest common factor. All right, so now we're going to do the reverse direction.
Like we're gonna start with that, basically.
So you're going to start with this and work your way backwards. So 14 log of x plus log of 5. So we just combine the things by multiplication. So it would just be log of 5x.
Okay, simple.
Start off with something.
Then it gets harder.
16 ln of x minus ln of y would be what?
ln x over y.
Ln of x over y. 18 1/5 log of z.
Oh, that's
Log
it.
of z raised to the 1/5.
And what's another way I could write it? I'm okay if you leave it like that, but what's the other way you could write it?
Like radical x to the 5th, or I don't know how to say it.
The 5th root of z.
Yeah, that.
Yes. 24 log of y minus log of z. And again, if you want to do this all as one step, that is completely fine. But if you want to do it in multiple steps, that's also fine.
Let's say log y to the 4th z.
Well, it's over.
Over.
Over, yeah.
Right to the fourth over z.
Yep.
That's a 7, not a z.
All right.
Yeah, it's like I did the z and then I stopped halfway.
Last one. I'm going to have you try it on your own,
Ooh.
and then we're going to go over it. 3 ln of x cubed y plus 2 ln of yz squared.
Jumping into the deep end.
You can do this one, you can do all of them.
No.
We're still reversing it, right?
Yeah.
I'm gonna try this like a little bit.
Yeah. I'm not gonna try to just.
anybody think they have an answer?
No. I have a answer, but it doesn't.
All right, what answer do you have?
Okay, I guess I'll say it. I have ln. I know that part's right.
No pressure, but if at least one of you gets it right, I'll give you a cookie point.
So ln parentheses x cubed y parentheses to the cubed, like it's all cubed.
Everything is cute.
I already think it's wrong. Is it wrong? Like, I don't want to keep.
Well, is that it?
No, I have more. And then parentheses y, z squared parentheses squared.
Okay, anyone else?
I mean,
This is confusing.
I do have one, but it's just, should I say it anyways?
Is it different than his?
Yes.
Then say it.
Well, no, doesn't help me have all confidence. It's different, so. Ln x to the 9 plus ln y cubed plus ln y squared plus ln z to the 4th. I don't think I'm supposed to take other parentheses though.
Okay, anyone else? Does anyone else need another minute to see if you can get a cookie point?
No, I would like.
Nothing is gonna save me from this.
Feels like I'm
No one?
Aw,
Oh, you
man.
do.
Crap, I got it right.
Oh my gosh!
Okay, so you just have to, basically you're putting the power back on top, then you have to put the power to each piece. Okay, just general rules of exponents, then you have to combine it, and the only one that you actually had to do anything with was the y's then to add them together.
I'm saying answers out loud so bad.
That was my first answer, but because I thought about if we were going the other way,
Yeah, how to do it.
wouldn't be able to separate the y's, but I guess that doesn't apply here. If you were going the other way,
Oh.
trying to get that answer, you would have to figure out a way to separate the y's.
Oh, yeah,
That was my thought process.
Oh, I didn't.
But I guess
Maybe
that,
it helped that I just
I guess
didn't
that
really
just
think.
doesn't apply in this kind of
Maybe it
problem.
helped that I just didn't really think.
Well, odds are if you had actually done this in the reverse direction, you would have written ln of x to the 9th plus ln of y to the 5th plus ln of z to the 4th.
Yeah.
And then you would have just put everything out front. So, yeah, a lot of times, going in the reverse direction, you won't actually always get back to that.
Okay.
So, yeah. All right, there's a little bit more to this section, but I'm not going to do it today because there's not time. But the problems for what we've done so far is 1 through 21, every other odd, and then there'll just be a couple more added tomorrow. So we'll finish the section, and you'll have tomorrow to work on it because there's not, there's 10 minutes, so you could theoretically finish it, but if you also are just now we're getting back into the school thing, and I'm not feeling it.
I